Hello, everyone, and welcome to this presentation. My name is Ramzi Lahoud of GitGuardian, and I'm here to talk to you today about hard-coded credentials or secrets and why it's important for any company to start dealing with this issue today. A quick overview, we'll talk about what are secrets, what is secret sprawl, why it's such a problem, take a look at how this problem is evolving, some examples of breaches and incidents that involve a few different companies, and talk about some strategies to deal with this problem. Finally, we'll talk about GitGuardian and our two solutions that focus on this topic. So first of all, a secret is any kind of digital authentication credential. There's a really wide variety of secrets. So this can be an API key. So there are many different types of cloud services that use API keys. It can be a username, password couple, an SSH key, database credentials, any kind of token, and it's a very, very long list. And it's only getting longer as more and more services are created. So a good way to visualize with this very busy slide, it's a kind of a visualization of what a modern application is today. So it's this collection of building blocks. You have what your application uses, for example, for credit card processing. You wouldn't build it yourself. You would maybe use Stripe. For search functions, you would use Algolia. As a managed database, you would use MongoDB. So that's an example in terms of infrastructure to host, to monitor, to test. You would have a range of different services that we'd use, like AWS and Datadog. Also, you have so many other types of services for like Salesforce, Slack, that your sales and other teams might require. And you also have microservices that you might have built yourself. And all of these will require some type of secret to authenticate their use and to interconnect all these different building blocks and to have a working application and be able to keep track of what's happening. So it's no surprise that these secrets are actually really prized by cyber criminals. Once you start to think about all these different services and systems they might give access to. And it also makes a lot of sense in that respect to that any organization that produces code needs to start thinking about secrets and where they're located and making sure they're kept safe. So another question you might ask is, it is actually a very well-known best practice that secrets should not be hard-coded. And yet, here, it is a reality that it does happen quite often. We'll take a look at how much a bit later. But what I wanted to talk about now is, why does it happen? And the quick answer is human error. It's a bit too easy nowadays to accidentally push secrets to the wrong location. You might push the wrong repository in Git. You might push the wrong file to your version control system. And there's situations where secrets might be exposed in logs. And one very common situation is developers who forget how commit history works in Git. So you might have a secret on a line of code and you just delete it, thinking that it's gone, but actually it's still visible in the commit history. And that's a very common mistake and something that attackers know where to look. They know that the commit history is a very plausible location to find secrets that were forgotten about, but that might still be usable. So it is a good, interesting talk about is what makes secrets a bit different from other types of vulnerabilities. So there's a CWE top 25 most dangerous software weaknesses list, and hard-coded secrets is in that list, in the top 20, I think. And it's the only one that is not a runtime vulnerability, meaning you don't actually require running software for it to be a problem. That's what's interesting about hard-coded credentials, is that it's the source code itself that can be exploited. And that has really big implications. Code is constantly being distributed and duplicated and cloned. And so once you have a secret in one section of your source code, that secret should be considered compromised because it's going to spread. It also is a situation where secrets are just accumulating over time because it's kind of like blocks of Tetris that keep accumulating. And if you don't have good detection in place, it's really hard to know and to start clearing those blocks because you don't even know they're there. So it's a tricky problem and keeps getting bigger. And that's why it's important to deal with it as soon as possible. On this topic, so I talked about how do we know that this problem is growing. So one interesting place to look is GitHub.com. So not only is it the location where the biggest place where all developers share their code, it's the most important location for open source projects. It's also the case that GitGuardian has been monitoring GitHub.com for the last 4 years. So all activity on these public repositories on GitHub has been monitored by GitGuardian. And what we found is quite interesting. So in 2021 alone, there were 6 million secrets that got leaked. And that was twice as many as in 2020, which was really, I would say, impressive. Also, we're seeing just an increase as well as of usage on GitHub and more developers joining. So it's really an interesting space to keep an eye on. It's not just us and our view on GitHub.com. A few different third-party reports, for example, the recent data breach investigation report by Verizon, they say that there's been an almost 30% increase in stolen credentials since 2017. And another IBM report, quite recent, is saying that the use of stolen or compromised credentials is actually the most common cause of data breaches, and that these breaches also have the longest life cycle. It takes 243 days on average to identify such a breach, and another 84 days to contain. And we'll talk about why these incidents are especially tricky to deal with in a few examples. I have 4 different examples to talk about with you today. The first one is actually involving Uber. So this is a very recent attack that happened. So we don't have all the information yet. I can give a quick overview of what we know so far. So this attack started with a social engineering campaign that targeted Uber employees. It yielded access to a VPN, which in turn granted access to Uber's internal network. Once on the network, the attackers found some PowerShell scripts, one of which contained hard-coded credentials. And these were for a domain admin account for Uber's privileged access management system. So using this admin access, the attacker was able to log in, take over multiple services and internal tools. It's actually quite a long list involving AWS, Google, Slack, even a HackerOne admin console, and Uber's internal employee dashboards, and even some internal code. So the only takeaway here at this early stage is that this is a good example of how one credential can then give access to more credentials, and how once one system is breached, it can allow attackers to move laterally, and this enlarges the damage radius. And this goes back to what I was just saying previously about how incidents involving stolen credentials can really be hard to manage and take time to mitigate. The next incident or breach we wanted to talk about involved Microsoft and the quite famous now or infamous Lapsus group. So this group has been really focused on obtaining internal source code from different companies. They also had recent leaks involving where they leaked source code from Samsung and NVIDIA. And this one from March involved 250 Microsoft projects. So Microsoft has been quite confident in saying that the damage here was very limited, and that anyway, their internal source code is not really secret for them. It doesn't represent a big issue for it to be exposed. Nonetheless, GitGuardian ran the same scanners that we run to protect our customers' source code and tried to understand how many secrets were present in these projects. And we found actually 376 secrets inside of these projects, which is actually half the amount that we would normally expect to find for such an amount of code. So this does show that Microsoft is quite security conscious and has been making an effort to reduce secret sprawl. But even in this case, there are still secrets there that need to be dealt with. And so we also took a look at the types of keys that we found. These are keys that are being used within an application, and it's possible they might have granted access to internal systems and infrastructure, although we cannot be certain. The next interesting one is another source code leak, this time from Twitch. So in this case, because of a misconfigured server, Twitch's entire source code was made publicly accessible. So we're not just talking about the main Twitch application. It was really from across the entire organization. So it included everything from their backend services, data relating to companies that Twitch owned, secret projects that no one was supposed to know about, and a lot more information. And actually, it revealed the amount of money that Twitch's streamers were making. And so a lot of the media attention was focused on that juicy detail. But on our hand, GitGuardian, we scanned the code to understand how bad the secret sprawl situation was at Twitch. And so these were 6,000 repositories and 200 gigabytes of code. And this revealed 6,600 secrets. You can see here an overview of the types of secrets that were found. Number one being these 194 AWS keys. And so, yeah, it's definitely interesting in itself to see. And this is pretty much in line with what we'd expect for a given company. And what's also interesting here is that once the attacker got access to this source code leak, they immediately leaked it online, which meant that Twitch was aware quite quickly about the breach and was able to start revoking these secrets and reducing the potential impact. What's quite scary to think about is that attackers could have decided to keep this source code's leaked secret and could have started leveraging these 6,000 credentials one by one. They could have started selling them on the dark web, which is actually quite a common occurrence. And so in a way, it might be a bit counterintuitive, but by making this leak so public so quickly might have helped Twitch reduce the damage by allowing them to act quite quickly. The last breach I want to talk about is also very interesting, and this involves CodeCov, and this is from January 2021. So first of all, what is CodeCov? It is a code coverage tool, and meaning that it lets a portion of your code is being tested automatically, and it sits inside a CI/CD pipeline and looks at your application's code while it's being tested. So it's actually a very popular tool used by 20,000 customers at the time of the breach. HashiCorp, Rapid7, Twilio were among some of the big names that released statements about how this incident affected them. What happened in this case? So attackers actually, with using quite sophisticated methods, exploited a mistake in one CodeCov Docker image. This actually contained a leak credential within this image, and they used this flaw to modify a script that started sending environment variables from the CI of CodeCov customers to a remote server. And so from that point, the attackers had a lot of different options for how to use these secrets. And basically what they did is use them to gain access to private Git repositories, so private source code, and then try to exploit the data within. So again, it's showing how much source code is a prized asset and how secrets are also can be so easily leveraged to gain access to all kinds of different systems. And what's super interesting is it only started with one leak credential in a Docker image, and then ended up with a very far-reaching attack that impacted potentially 20,000 customers. And so this is really a very interesting example. So next, we'll talk about a few different prevention measures. There are a few different best practices that we can talk about at the start. So the first is, of course, secret management systems or vaults are really good to be able to use, although hard to enforce. Making sure that your developers are aware of best practices with workshops and so on, and just making sure they are well aware that you should never be storing secrets inside Git repositories. It's also very good. Short-lived credentials are also nice to be able to use, although there is a saying that behind every short-lived credential lives a long-lived credential, if that's correct to say. Of course, it's also very good to have good access hygiene, making sure that APIs, keys have the correct scope, and always giving them minimal scope that is necessary when issuing these keys. And lastly, automated secret detection to be able to understand what secrets are already present in your source code and also prevent new secrets from entering your code base and spreading. So, of course, GitGuardian specializes in this last aspect, and so we slowly get to talk about what it is that we do. Beforehand, we can just also talk about what makes this challenge kind of unique, especially when talking about internal source code. So as I've already mentioned, when it comes to secrets, you need to scan everything and all your source code. Even if it's secret lying in your Git history, it still needs to be found and needs to be dealt with. And so will mean that you're scanning, you cannot just focus on one particular branch or on the current version. And so that means a lot more code to scan, potentially a lot of more secrets found. Second point is when detecting secrets, it's important to have really high accuracy, a low number of false positives, because again, we are finding a large number of secrets. We'll talk about this in a second, exactly how many on average. And if you don't have good performance, you're going to end up with a lot of false positives and it's going to create a lack of trust and will make it much harder to deal with the problem. And then also, when you talk about detecting, it's not the only part of the puzzle. There's also remediation. And there's often the case where multiple teams, for example, are using the same credential across a company. So you need to understand the implications of what this secret gives access to before just revoking it. And so there's a lot of work that goes into remediation and a lot of collaboration that needs to occur between different teams and between the AppSec team and their developers. So that adds also another challenge. Going back to the idea of number of findings. So we have a lot of data that we can use to obtain some averages. So if you take an average company that has 400 developers, 4 application security engineers, we would find on average 1,050 leaked secrets after scanning their entire code base at the beginning of this, for example, setup. And each one of these 1,000 secrets actually will be on average leaked multiple times, 13 different places. So this one unique credential found in 13 different places on average. So if you do the maths, you end up with one AppSec engineer having to make sure that 3,400 occurrences of secrets are managed. And so you can easily understand how this is quite overwhelming for the application security team, and there needs to be some kind of automation in place to make it work. And another topic is prevention. So if you look at where secret detection should be implemented, server side is the first easy box to tick. You need to understand what secrets are reaching your version control system, your GitHub, your GitLab, or so on. And you need to know how many there are already and if any new ones are entering. This is where the threat lies, and you need to make sure that you have the truth about what's currently living in your server. However, because of what I just mentioned previously, the amount of secrets that exist, you want to make sure that you're not adding to the problem and stop this flow of secrets reaching the server as soon as possible. And so that's why it also is important to shift left and implement some kind of secret detection measures earlier on in the process, client side. And there are a few different options, and every company will have a different best solution for them. So let's talk quickly then now about GitGuardian. Quick word about the company. So we are the leader in secret detection. We've scanned billions of commits. This has allowed us to really fine-tune our detection engines and also fine-tune our best practices and our advice for how to handle this problem. We have many customers who now work with us and trust us and love our solutions. We also have the #1 security app in the GitHub marketplace, which shows also that developers appreciate our solution and are happy to use it. So we have 2 main solutions that we can talk about. The first one is really focused on this cleaning up of internal source code and internal systems. It's aimed at AppSec teams, DevSecOps teams, and focuses on the repositories that your company owns. It allows you to perform real-time detection server-side, but also implement prevention measures client-side. And it can also allow you to do checks in your CI/CD. And very important, it allows you to facilitate remediation by automatically giving access to the relevant people so that they can provide information about this secret and enable your security teams to act with saving as much time as possible. Our second solution, which is actually quite different from the first one, it's more of a threat intelligence tool and also attractive for red teams who are trying to understand the exposure of your company. This is focused on GitHub.com and everything that's public on GitHub.com. So we will scan any repositories that are maybe official open source repositories. The most important and interesting thing is monitoring personal public repositories that belong to your developers, because it is quite an easy mistake to accidentally push corporate credentials, personal repository that's public. So this is a quick overview of our public monitoring solution. It has an overview of everything that's happening on public GitHub and allows you to visualize a subset of this and give you accurate information about potential leaks that might involve your company. And we also allow you to search within our database to potentially find other types of leaks with our Explore functionality. So that's all I have for you today. Thank you very much for taking the time. We'll be happy to answer any of your questions.